In this video, I'll show you the components on a closed-loop cooling tower system and walk you through a preventative maintenance inspection.
So here we go. This is an account that I have. As you can see, I got two cooling towers here right next to each other. Same model, serial number. You got a little cooling tower over here. So I just wanted to show you guys what I typically do on service for these cooling towers. Floor's a little dirty, needs some cleaning. See a little foam down there with the water and such. Yeah, water's not looking too good. So it looks like this tower needs some flush and a cleaning. Basically with the power washer as well. The fill inside is not too bad from the inside, but I'll show you guys a view from the outside of this fill. In any case, what I really wanted to concentrate on is going up those ladders and checking the pulleys, the fan pulleys for this tower. So you can see you got two fans in this cooling tower, powered by one motor here. So you got two belts. So the pulling the motor up there can accommodate two belts. So that's the first one. And you can kind of see that's the second one over there. I got to recommend to the customer that he's got to replace the bearings on his cooling tower here, just because looks like the bearings, I cleaned them up already, and I added this little blue Zerk fitting cover just so dust and crap doesn't get inside my bearings there. So there's where you place the grease gun for in there, and then just start pumping grease in there. Like I said, it looks like they greased bearings prior to me getting this account, and they blew out the bearings, right? You're not supposed to have grease all over the place like that. That's a sign that the packing inside that bearing has failed, and all the grease is just starting to spill out. In any case, this is what I'm recommending for the customer to do. He needs to replace that bearing there and that bearing there. But as you can see, it's shaft from the fan assembly down to there. So luckily, I can run one cooling tower and have this one shut down while I replace the pulleys. And it's the same thing on the other. You got the same thing. You got two pulleys over there on that. So a total of four. I guess these would be called the pillow block bearings when we refer to them. If anybody has a better description of them, I would like to know. But as far as my knowledge, this is what we call them, the pillow block bearings. So currently filming this on my GoPro 11. So I carry it on the job sometimes just so I can document everything that I see. You can see that's the motor. So this is what we refer to as a motor rated for cooling towers. It's all sealed. You can see it has a little cover up top so no water gets inside of it. It does have a grounding ring to prevent the shaft currents on deteriorating the bearings inside this motor. The motor we replaced about a year ago, so it's still working like a champ, right? And this is what I do on my preventative maintenance is, check out my equipment, make sure everything's working properly. I'll check the belts here. I'll spin it by hand just to see what the condition of the belt is. And then also checking the tension, just seeing how that is. And then I do check the other belt as well. Obviously, you can see over here, when one fan turns, the other one does as well. You can kind of see the fan blades. Plus, what you do on a cooling tower maintenance. And there's the vibration switch. So that switch right there will detect any crazy vibration and stop the cooling tower from spinning so it can protect itself from catastrophic failure. So you'll often see these for cooling towers, vibration switch, and it has a manual reset button there. your chemical station, chemical to prevent the total dissolved solids, the TDSs, and your condenser water here. And you can see in this tower, it's overflowing a bit. And that's what that is. That's the overflow. So you actually have two drains on these cooling towers. You have a overflow drain, which is that one. And then you have your main drain, which is that one. You can see the overflow drain is higher than your main drain. So you want to open the main drain when you're cleaning these cooling towers so you can drain all the water that's inside of them. So I know I've been saying cooling tower, but the correct terminology for this component here, it's actually a fluid cooler. I'll show you guys why it's a fluid cooler. You can see it's a pretty big, right? So this particular, it's a cooling tower, but we call it, it's a closed loop cooling tower. Better yet, we can just call it a fluid cooler. So this has a circulating pump that grabs the sump water from down here. That's the pump. Sucks the water out and shoots it up through this PVC pipe all the way up. And it's just that same water over and over. So that water is used to cool the closed loop water. You can see right here, this right here in the main condenser water for this building. We got condenser water return, and this one's missing the label. It should say condenser water supply. So you can see how big this pipe is, right? Coming in the building. This pipe right here, you can see on the couplings here, 10-inch. That's the size of this coupling, so I can tell that this is 10-inch pipe going right here. You can see we got the pumps right here. These are massive pumps that pump water throughout this whole building. And only one of them's operating right now, which is this one right here. The other one's kind of off. They don't really need two pumps operating at the same time. One of them's capable of maintaining the load, but they have a second one for redundancy. And so throughout the day, they switch back and forth so they can have an even run time. This right here is your waste strainer. So you shut the system down. There's a screen in there that you can pull out, and it's filtering all the water coming back in here before it enters the pond. So as you can see, we got some piping coming in and out of the tower in here. Those top pipes, they're labeled as an out. So that's water leaving in the pipes. They're down there, and there's a label there that says in. So that's entering water. So water, condenser water enters through the bottom and then comes back out of the top. And then you have water that rains down. Inside there's a tube bundle. I think it's a copper tube bundle, not sure. But in there, there's like a heat exchanger, copper tube bundles. And then water rains on top of the tube bundle, cools it down. And then the water comes right back out of here and it's cooler. As you can see, you got thermometers here. 3 thermometers as the water's going into the tower. And then you also have 3 thermometers as the water leaves the tower. This bad boy right here, this is your expansion tank for the system. And this expansion tank's pretty neat. It has a pressure gauge on it. And then you also have the sight glass telling you if the bladder has been compromised or not. So this type of expansion tank has a bladder inside of it, a rubber bladder that expands and contracts with the pressure of the system. Moving on here, this big tank right here. This is what we refer to as an air separator. That removes the air from the system, and you can see up there, we have a automatic vent with a valve open, so it's constantly venting whatever air is grabbing from the system so the pumps won't get any of that air. So you can prevent cavitations. This pipe right here, this is the makeup water line. You can see it's labeled city water. So this is what feeds water back into the sump here. It keeps it filled up, and it's controlled by this float valve. So this is another thing that we check on our preventative maintenance. Right? And look at the color on this water. Yeah, it needs some attention. What I want to show you on the exterior side of the tower, and you can see this white mildew. That's where the buildup really happens, on the exterior of the towers, mostly. And this is where we use the pressure washer to clean all that stuff out. So we do this twice a year on this tower. We power wash it and then flush it out. You can see that the system is pretty involved. Here's your breaker, right? You got breakers for cooling tower 1, cooling tower 2. Then we have breakers for our pump 1 and 2 right there. Breaker panel right here provides power to the cooling tower VFD. So then we have a disconnect here. And then downstream of that, we have the VFD is the one that controls the speed of those fan blades that I was checking. Currently, as you can see, I have everything up right now because I was in that cooling tower. I didn't want that thing running while I was performing my service and inspection. Then here's your second cooling tower, VFD. Here's the disconnect switch for it. This one's on. So you can see inside this electrical box where the VFD is located, you got a bunch of components in here, right? And then one of the things I wanted to kind of point out was we need to be checking these little circulating fans, right? Some of them are exhaust fans and some of them are intake fans. We have to be able to inspect these fans and make sure they're running properly, because they're the ones that keep the cabinets cool for that VFD. If that cabinet gets too high, that VFD will shut itself off and turn off on thermal overload because it's too hot. These are the little 3 thermometers in that control. When those fans come on and off, so you're able to manipulate and test those fans if they work just by adjusting the temperature there. And you got some fuses for the VFD. You can see that's what it's running at right now. Running at 60 hertz. I have it in hand because I have the other one off. I'm running this VFD 100% in order to maintain the load while I have one cooling tower off and I'm working on it or servicing it. So here's, you got contactors. You got a contactor for the VFD. And then you got a contactor that goes straight through us. You decide to just go give it 100% power with no speed control. You can see this is how everything's wired up. That's the line side power coming from that disconnect there. Then obviously this is your load side. Down here, these are the wires that are routed to the motor. As you can see, there's a temperature that got triggered, and now the pump is starting to run with water raining down. So that water is the one raining down from up top all the way down here. So you're using water to cool other water or condenser waters. Then here's your spring isolators. These will provide your shock absorption and vibration mitigation for your cooling tower, so the tenants down below don't feel all the vibration from this cooling tower. Right? So over here, so we got our circuit breaker box, VFD1, VFD2. This is what we call a pool box. It's just an electrical pool box used to access the junction to route wires in any direction that we want. We got a convenience outlet here. Typically, that's when we refer to these outlets that are around our systems, convenience outlets. So you'll see one out here too. This one's more of an outdoor rated one because it's got a cover on it. And it's providing power for your chemical station here. This is the control center of this system. As you can see, this is the main controller that controls all the devices, and then a series of relays here that get triggered when this controller says to do so. And then you got a terminal block here with all the wires on all the control side of things. Got another outlet over here. This over here looks like you got a transformer with a circuit breaker switch. So those transformers with that circuit breaker reset switch are pretty handy in case you short something out on the low voltage side. It just trips that circuit breaker, and that way you don't have to go buy a new transformer. So they do sell those at the supply houses. However, they are a little bit more expensive, but they actually, I think they serve a good purpose. And then you can kind of see, I wrote my notes here in case another technician comes out here and needs to know how to reset the system. I put my notes on what he needs to do. Then we got your data plate here, all the information for this control panel and how it was built. More notes right here from my colleague. He wrote this down. So these are all chemical stuff that from the chemical company that they leave here behind. So this is the other cooling tower. You can kind of see, got the circulating hot, and it's running. So you can kind of see it's a little bit on a raining action here. That's your overflow. This one, the water level not super high, so it's not overflowing. You can kind of see we got boilers here as well. 2 Ajax boilers. And then we got these pumps. Pumps are pretty massive. You can kind of hear that noise in there. You suspect those pumps are too big for this system, and that's why they're causing this noise, because on the suction side, they are operating in a negative pressure. And let me show you real quick about those pressure gauges that I have on there, and I'll show you running in a negative. So here, the kind of pressure and then on and what the pressure is, the helping and out the pump, and also get a pump angle. And you know, the device is grounded right off the side. This part is light about it. And typically see those fit there. And then we'll see it there. It's hard to tell. The link reaction there. I want to check your question. I'll open this down for here. And then see. Other way to trade to zero. And the chest is running in a negative. And one goes wrong. The blood is so much fluid. And then just jump through that. I'll pull you back up. And then we'll see what's saying. The power pressure is on this hole. Here's my valve. Now I'm going to see how much it's not. And I'd be riding along 70 psi. I'll pull my valve back up. Got thermometers and everything, same as the other cooling tower. But in a nutshell, just wanted to go over this cooling tower, or I'm sorry, closed loop cooling tower for fluid coolers. And in order to get up top, you do need to put an extension ladder up. And I'll show you guys what size extension ladder we need to put up here. And it goes to a common drain, so both drains are connected from these towers down to this common drain. So you can kind of see what we need to do, we need to put this ladder up here just to climb on top of that ladder up there and look at the spray section of this tower. In any case, that has been it for this account.